So far, we've been the only user of our database. But in the real world, it's quite possible that two or more users will try to access the same data at the same time. This is what we call concurrency. Now, concurrency can become a problem when one user modifies the data that other users are trying to retrieve or modify. In this lecture, you're going to learn how MySQL handles concurrency by default. And then over the next few lectures, you're going to learn how to minimize concurrency problems. So we're going to simulate two users trying to update the points for a given customer at the same time. Let's go to the home page of MySQL Workbench and open a new connection to our server. Now we have two separate connections or sessions. In our first session, let's start a transaction. And by the way, we should make sure that we're using our SQL store database. Okay, so we start a transaction and give customer number 1 10 extra points. So update customers, set points to points plus 10, where customer ID equals 1. And then we commit. Now don't execute this yet. Let's copy this entire code and paste it into our new session. Let me zoom in. All right, beautiful. Now, before executing these scripts, let's look at the customers table and see how many points customer number 1 has. So here's the customers table. Customer number 1 has currently 2,273 points. Now back to our first session. We're going to execute this script line by line. So using the shortcut that you learned earlier under the query menu, execute current statement, right? So let's execute the first line and then start a transaction and then update the points. But we're not going to commit. Now we go to our second session. Let me close the navigator panel. All right, here's the second session. In this session, we should also use our SQL store database, start a transaction, and then try to update the customer. Now look at this spinner here. This update is running. Because when we executed the first update, MySQL put a lock on the customer row that we updated. So if another transaction tries to update the same row, it has to wait until the first transaction is complete, either committed or rolled back. That is why we had this spinner here. Now, this operation timed out. That's why the spinner disappeared. So I'm going to repeat this step one more time. In our second session, I'm going to start a new transaction, update the customer. Okay, it's waiting. Beautiful. Now back to our first session. Let's commit the changes. All right. Now let's go to the second session. Update is no longer running, so it affected one row, but the changes are not committed yet. Let's commit the changes. All right. Now back to our customers table. Let's refresh the result and look at the points for customer number 1. We have 20 extra points here, because each transaction increased the points by 10. So if a transaction tries to modify a row or multiple rows, it puts a lock on these rows, and this lock prevents other transactions from modifying these rows until the first transaction is done. Either it's committed or rolled back. So with the default lock-in behavior in MySQL, you don't have to worry about concurrency problems most of the time. But there are special cases where the default behavior is not sufficient for specific scenarios in your applications. In those situations, we can override the default behavior, as I will show you shortly. Next, we're going to look at the common concurrency problems and how to solve them.